Hi guys, in this video we are going to solve this problem collecting numbers. This is an extended version of this previous problem collecting numbers. So if you have not solved it, then you can solve this first. Now let's come to this problem only. Now here we are given an array that contains each number between 1 to n exactly once, and our task is to collect the numbers from 1 to n in increasing order, and we have to traverse from left to right and collect as many numbers as possible in each round. And different part in this problem is this m operations, in which we have to swap two numbers in the array, and then we have to tell what are the numbers of rounds after each operation. So let's see how we can solve this problem. I have taken this simple input 42153. In the previous video we saw that like we can solve it like this. Like for 1 we need one trip only, for 2 and 3 we can do in another trip, and for 4 and 5 we can do it in another trip. So total 3 trips we needed. And how we can know that we need 3 trips? So basically we can sort these like 1 2 3 4 and 5, and we can also maintain their indices, original index. So for 1 we are having 2, I'm taking 0 base indexing. For 2 we are having 1, and for 4 we are having 0, for 5 we are having 3, and for 3 we are having 4. Now those which are in same trip, for those like these indices will be in increasing order. So for 0 3 also they are in same trip or round, I will call them trip. And when a new trip is starting, so there this order is breaking, increasing order is breaking. So like 2 is not less than 1, so we can know that a new trip has started. Similarly for here also, like 4 is less than, not less than 0, so we can say a new trip has started. And in case of this one, so here we are starting a new trip, so that's it. Okay, now let's see how we can handle update as well. So let's check this 1 and 0. So we have to swap this like 4 and 2, this and this, and then we want to know what are the numbers of rounds. So if we swap this 4 and 2, then we will get like this 2 4 1 5 and 3. So basically what happens, like for 2 and 4 their position got swapped. So initially we are having like this, and after swapping we will have like this 2 for 2 and 4 we are having like 0, this and this will swapped, so 0 4 and 1 and 3. Now we can do same thing like this earlier we did, but this will take time, so we are going to optimize this. Okay, so first what we are going to do, for this 1 and 0 we are going to revert all changes we made because of this 1 and 0. So by revert I mean, like we can say for this ones left, like we are having 2, we can check this 2 and 1, like whether there is an increasing order. So here 2 is not less than 1, so we can know that because of this 2 and 1 there one trip was getting added. So now we can subtract this one, because we are going to remove this one. Similarly for this 1 or 1 4, like there no trip is getting added because 1 and 4 are in increasing order only. And in case of this 0, for 4 and 0 we can say they are not in ascending order, so we can again subtract 1. In case of 0 and 3 they are in ascending order, so we will not do anything. Now when after swapping this, so like this 0 and 1 will get swapped, so 0 here and 1 here. Now for this 0 and this 1 we can check what are the trips are now getting added. So for 2 and 0 we are adding a trip, like 2 is greater than 0, so we will need another trip. And for 0 and 4, like they are increasing order, so 0 and 4 are in same trip, so no need to add another trip. In case of this 1, like 4 and 1 we can add another one, and 1 and 3 we don't need to add anything. So basically we added nothing, like these are -2 and these are +2, so in this case we added nothing. Okay, now there is another case when these positions are at adjacent. So let me write it. So write it again, 1 2 3 4 5, and now we are having like this 2 0 4 1 and 3. Now let's say we have to save this 0 and 4, so we have to save numbers which are at 0 and 4. Now for this 0 we can check, like in left we are having 2 which is greater than 0, so we can subtract 1. In case of this 4 we can check this 4 is greater than 1, so we can subtract again 1. And in case of this 0 and 4 we can say, like there we are like increasing order only, so we can just ignore this. And now after swapping we will have like this, so this will become 4 and this will become 0. So here we can check for 2 and 4, they are in increasing order, so we will do nothing. In case of 4 and 0 they are not in increasing order, so we can add 1. In case of this 0 and 1 we are in increasing order, so we will do nothing. So basically this one will cancel out with this, so total number of trips will decrease by 1. And if you see, like 0 1 3 will be in one trip and 2 4 will be in another trip. So that is how we can handle when they are in adjacent after sorting the array. So I hope it was clear. Now let's see how we can write code for this. First we are going to take input. So A I have declared as a vector of pairs, and first element in this pair will be the value and second element will be index. Then we have sorted this array A, and after that we are checking whether we are breaking that increasing order. So if that is the case, then we are incrementing our answer by 1. Then in this position vector we are storing mapping from their old index to new index. So for AI, old index is AI dot second and new index is I. Now u and we are taking input, and u and we are in one base indexing, so I am decrementing them by 1 so that they become one base indexing. Now whatever changes we have to made like because of u and we are going to revert them. So that is why I'm passing this -1 here. So if I go to that update method, so here I'm ensuring that this position of u should be greater than less than position v. So if it is greater than u position v, then we are swapping this u and v. So this position u is this new index of u basically. So I want to ensure that new index of u is greater than less than new index of v. Now this I is this new index of u, and j is new index of v. Then we are checking for whether for AI we are having AI -1 dot second as greater than AI dot second. So if that is the case, that means we are breaking that increasing order, so we are updating this answer. Similarly for this j, we are checking in the right whether we are breaking that increasing order, and same and in case they are adjacent, I and j are adjacent, we are checking like AI dot second is greater than aj dot second, and we are changing our answer. And in case they are not adjacent, then for AI dot second we are checking whether it is greater than AI plus 1 dot second. So basically for AI we are checking for its right, like whether AI's original index is greater than this AI plus 1's original index. So if that is the case, then we are breaking that increasing order. And same for AJ, we are checking whether AJ -1's original index is greater than AJ's original index. If that is the case, we are breaking the increasing order, and we can update this answer. So first time we are passing -1, so answer is getting added by -1. So answer plus equal to minus value, so answer is getting decremented by 1. Now this AI dot second is storing its original index. Now when we are swapping these u and v, then their original index will swap. So we are swapping this AI dot second aj dot second. Then in this position vector we are storing their mapping from old to new. So because we are swapping this old, so that is why we are swapping these as well. And then after swapping, because of this u and v, whatever changes we are making, whatever changes we will be added to this answer variable, that we are handling in this update method. So this time we are passing 1 here, because this time we need to not revert but add those changes, and then we are just printing the answer. So let's run this. Yes, we are getting 2 3 and 4, that is correct. Now let's submit it. Okay, so we are getting correct answer. So if you had any difficulty in understanding this solution, then you can ask me in comment section. And by the next video, thank you guys for watching this video, and I will see you in the next video.